Hi guys. First time in Newcastle, so that's a pretty good experience. I've come down from Liverpool today, and I think sometime last 3 months I've seen Peter down there, down in Liverpool. He's been telling me how developed Liverpool has been, gotten investments and whatnot. And he sort of like undersold Newcastle to me. So when I was down here, first time when I've just got to it was like, oh, that's not what I was expecting. It's like a really beautiful city. So, anyways, a little bit about me. I'm basically software engineer, and my passion is not really software, but creativity. Software to me is basically being expressing a part of that creativeness, um, developing solutions that are, I would say, beautiful. Drives me to make things that are beautiful. Um, I also co-host a .NET user group meetup in Liverpool. It's called .NET Liverpool. After this, there's some swags here, keychains. If you could grab a couple of those on your way out, that would be cool. And during the week, I do some software engineering work at Liverpool for a data company. It's a software engineering company, but it's a data company. We basically um, um, collate data for legal companies in the real estate industry. Um, More about my talk now. Business as first class. It's a fancy name, talking about business as first class, but over the whole covering and everything, is really a domain-driven design talk. Clean architecture, domain-driven design, the whole package. And the entire point for this talk is we build products, we build software for fun, but we get paid to do that. People pay us to use products we build, and the entire idea or the entire use of people paying us, the entire reason people pay us for our software is that something they need something from it. It does something for them. It does a purpose. It serves a purpose, and it stands to reason that when we build software, that software should focus on what the users of the product need it for, rather than the technology the software is built for. So I'll show a couple of slides, and before that, I'll just go through agenda of what we're going to do today. So as software engineers, something that's really important, or should be really important to us, is why. It's a question we would keep asking throughout this talk. Why do this? Why do that? Or why don't do that? Because yeah, it's really important to know why before for any endeavor we take in software. Know why. And first thing we do is I talk through a couple of slides about the why, the problem we have, the problem we could have, or the problem you've had, or would probably have in a couple of months, and move towards next steps, possible solutions, clarity, isolation. We all like modularizations, modules, components, trying to isolate, get things into little quantas, components that do what they do right. And we speak about language, business language rather than programming language. Again, all languages, but what's more important, the programming language, the context, the technology, or the business. And finally, I'll talk about a few technical patterns that could support, basically speaking, the business language in software. So the problem, how many of you've been in stand-up meetings with product owners? How many of you have had meetings go this way? Yeah. When you're asked about the product you build, how many of you go, I build a microservice or modular architecture on AWS using Redis for that's actually the view I get a lot about products, but that's not the view users see. That's not the view the product owners see. What they want to know is, what does this product do? What do we serve? What purpose does it serve? What exactly do I gain by participating, by using this product? They don't care the technology. They don't care about the technology. They don't care about what you've done to make it so good, why it's so fast. All they need to know is, does it do what I need it to do? And I'll give another little example. This is basically trying to come up with something that explains what I'm trying to talk about. Might not be very realistic to do something like this, but this is a business process, a business function. I'm not calling it an endpoint, an API endpoint, or anything like that. This is a business function. It does something, but what does it do? I don't know. This receives input from users. It does some things with external clients, does some sending, does some publishing, gets information, estimates rights. And how do I tell people that maintain this, or someone that goes through this later on what this does? I have to do a whole lot of this, tell them what this particular block of nice looking, very fast and effective code does. Hey guys, I know it looks all gibberish, but this actually just sends information somewhere to tell them we've updated what we use in calculating price for other products. And that's actually, yeah. So what's the problem in all this? You develop software, it's fast, it's effective, it's nice, but where's the business purpose? Where's the function? It's not in the product. The product you've built itself does not know what it serves. Any other person working on that product, you working on that product a couple of weeks later, do not know what that process, that product does. All you see, all what you try to do is try to decide or go back to hunt down what this boolean value or this bytes you've declared here actually means to the business. When we all love working with product owners that decide on what the business needs and never have to change their minds on what they want that particular business function to do. And then when they change their minds, we now have to decide, oh, we've done something somewhere to book rights, but what does that? Where have we done that? That's because the product itself doesn't speak the business, the product speaks technology. What does that mean for business owners? It means when they need to make business decisions, business rules, they or we, there's like a communication gap between what they see and what we see. When they say we need to change how we determine priority for this particular process, what we hear or what we see or what we have to translate, we become translators, basically Google translators, where we go back to translating. Yeah, we need to send messages to a different queue now. And that's not what the business is about. That's not the change they need. Businesses are dynamic. Dynamic changes means we need products that reflect those changes. We need products that say, I need to do this. And the product itself says, this is what I do it here. And when you come to the product, you know it says this and you're sure it does that. And a little side note of something else that happens when you build products like this, products that focus on technical implementation, technical details, is our fancy word coupling. Fancy, yes, but very much realistic. This little piece of software here does price estimation, or rather updates something else that does price estimation via like a pop sub system. It gets that information from another system via HTTP as mode of transport. And what does that mean for us? It means this particular system, for one, is dependent on a whole lot of moving parts. This does an entirely different thing. It creates write requests and it does an entirely different thing. This is actually not something a lot of people would do, but it's something people would do as well. It does a whole lot of stuff. It does do what it does. It's been tested. It does what it does, but it does a whole lot more other stuff than it's meant to do, because we try to have a lot of business rules, a lot of decisions within one process, because it's easy to reach. It's where we've seen it. Those are the tools available to us. Basically, we have all those rules inside one system. And what is the solution, or a solution rather than this solution? Abstraction, clean architecture, the fancy words, clean architecture, abstraction. And why does it help us? Um, just before I go, is there anyone here that's averse to clean architecture, fancy words? That's not really a fan. Okay, so I've spoken with a couple, yeah, I've spoken with a couple of people that are really not. It's obviously keywords. Industry likes to market and sell keywords. People get excited. Brand new tool, brand new hammer, everything becomes a new. It's patterns, architectural patterns, software patterns. They exist to help you. They don't exist to be tried out because it sounds fancy. It exists to solve problems when problems exist. And this talk is about adding more tools in your toolbox so that when you come across a problem, you're able to solve them. And yeah, clean architecture, designing according to contracts, Quanta. So I was speaking with Peter earlier about this talk, what clean architecture is, or how I'm trying to explain it. And rather than talking about coding patterns or strategic patterns, let's use a perfect example is given earlier. A television. This television to us is basically a display output. That's all it does. This same information I'm getting here, I'm also getting on this PC, and I could also get on the phone, is a display output. Does the mode of display, does the um, technology I am using matter? Does the specific technology matter? Not in this context, no. What matters is the information. The software delivers information to an output device. It knows it delivers and receives information or commands from an output device and delivers information to an output device, but it does not care about the output device. And that's what clean architecture is contracts, is telling the product, we have contracts for a process, a procedure, a product, anything that does this. And I depend on, I know this product or whatever implements this contract, whatever implements this contract does this. But what I have defined is a set of business rules, a set of orchestration of how these different contracts should work to execute a business function. That's where the key bone of this talk is: being agnostic to technology, be agnostic to implementation details, being agnostic to technical details, and making the focus of the product its function, what it does. And that is clean architecture. Isolated quantas basically uh, pieces of software that often change together, that get modified together, move together, change together. Say a whole your whole product could be a quanta. You could your depends on the context and layer. A quanta is just basically piece of product, a piece of software that changes together. And that's what we try to do. That's what clean architecture helps us try to reason about. What parts of our system change together? What part of our system have logical parts that change together? It might not be logical, might be technical parts that change together. What parts of this system often change to serve a purpose? And I'll give sort of like an explanation on that of four different quantas, logical quantas in an application, four different logical quantas, the domain, presentation, application, and infrastructure. And I'll walk through those bit by bit. And the domain quanta, the business quanta, what it basically is it answers a question, and the question it answers is, what do you do? It answers the question, that's the question it asks the software. What do you do? not how you do it, not how well you do it, how fast you do it, but what do you do? Do you enable me write notes? Do you play music? Do you enable me book appointments? Do you enable me book hotels? What do you serve? What do you do? That's the question it answers basically. That's the domain for us. It's the core of our business. It's the meat of the business. It's what we get paid for. It's what the business gets paid for. It's basically everything to the software, the business, and what sort of concerns, uh, rules, business concerns, environments. So environments basically like business rules that can be like invalidated for absolute certainty that a business process does what it says it does. So basically, that is the domain for us. A piece of software that answers the question, what do we do? And creating a domain of an application, or rather designing or reasoning about what the domain is of your application. Um, Basically, an application, this is meant to be the entire business space of the application. What does the application do? Ask yourself questions like, what do we want users to do? We want them to book rights. We want to be able to calculate, give them discounts. We want to be able to manage the life cycle of started rights to ended right. We want to be able to update users on information of, that's basically managing the life cycle. What does it do? And this is like one big system, one big moving part that answers the question, what do we do? And they all answer the yes, it answers the question, what do we do, inside one big system. That's what the system does. But each of those parts do different stuff to achieve the big picture. There are separate moving parts that achieves the big picture. How do you calculate, how do you determine discounts for particular users? How do you determine payments for different users? Payments might not even be, it is basically key business function in the ride hailing app, because you do need payments from users. But how do you accept payments? How do you determine if a payment is valid for a particular order? How do you disburse payment? How do you report information to your drivers? Because they do need information on their activity. How do you report financial auditing, etc.? These are all different concerns within the business, different domains. They have different rules within them. They have different contexts within them. The information, the part of the organization, the part of the business that handles real-time location tracking or pricing or managing user onboarding, the information, the rules that they deal with, actually different within each and every one of these departments. These are different departments, and being able to identify each of these basic subdomains, basically domains within the business. That's one of like the strategic advantages you get from uh, that domain-driven design helps you think around in a process called context mapping. So what context mapping is basically a workshop where you reason about different subdomains, different isolated, or rather different units within the business that handle different functions and how they handle those functions. And not going to go too long into that, but basically being able to reason about identifying those subdomains is context mapping. It's a process. It's not a pattern, but rather a process between business and developers, understanding the business, the units that work together to make the business a success, basically, and identifying each and every one of those units. It's an iterative process as well, not something that you decide on or attempt to identify in one go at the start of the project, at a midpoint of the project, but something, information that naturally comes to the business or gets identified as the business progresses or matures. Another tooling is language. Um, that's a very good quote from Patrick Rothfuss. It's a long thing, so I'll share the slides later for this. But basically, what it says is it talks about the power of words and names. This is a book called The Name of the Wind. Patrick Rothfuss. It's a book that emphasizes the power of words, the power of like language, and as developers, I'm sure we're very attuned to the importance of language in software, the importance of language in business, the importance of naming and how difficult it can be. And that's another tool in domain-driven design. Ubiquitous language is the difference between um, asking for franchises within a business and storing organizations information within a database or data store, and the difference between asking, what shall I say, the journey in a ride and the geological information. So that's the geodata, the long lat information about the person user's location. It's language. What does this language mean within the context of the business? And does the entire team, both business users and software, speak that language? Does a language within a certain context mean the same thing ubiquitously, globally in the team? Um, that is basically a tool chain in domain-driven design, being able to reason about consolidating language across the entire business. And these are just basic examples of ubiquitous language going haywire, where you try to there's difference in the language the business speaks and the software speaks. The software speaks Google Marketplace location or geodata, while the business speaks customer location or live information. And disconnect in communication between the software and the business. Obviously, um, more moving parts, more disconnect, less dynamicity, less flexibility, less ability to be to um, maintain that product, less ability to work on that product, less ability to understand the product, because again the product speaks a different language in at its roots than the business does. Um, Another tool chain or another toolkit, the concept of bounded context. So very important to identify subdomains within the business, domains that perform certain actions, different units that perform certain actions. Just like the example we've done earlier with the um, booking, payment, life information, account management, and businesses are not isolated units. As much as we try to like isolate different units within the business, each of these units play parts in performing a business purpose, in facilitating a business function, and they all interact with each other. But each of those units also have isolated rules that must be obeyed within those units. There are different. Oh, and if we have that, the different rules that must be invariant, basically rules that must be followed within those contexts, but they do still have to communicate with each other. So how do we make sure that these business units work together without having information or concepts leak between components? Something that's age old, encapsulation. That's bounded context, encapsulation. Basically, within this context, within this business unit, these are our rules, this is our language, and Every other place, and any other unit of the business have different rules or languages that they obey, that they conform to. But within this context, within this encapsulated unit, these are the rules, these are the language, and this rather toolkit helps you reason about being able to design products that both function as isolated units. The ideal program that is isolated does the single thing without knowledge of any other system outside it, does what it does and does it so well, but also communicates with other um, contexts, other business subdomains to facilitate a business function. Um, yeah. And something else that you could see is an advantage within bounded contexts. We go back to language. This time around, journey route. Within the business domains, for this particular example, I've isolated three hypothetical domains. A booking domain that's concerned with booking rights for users, um, the life cycle of the ride, the ordering of the ride of for each users. It's a single unit. Within that context, the business defines rules. The business defines processes that facilitates those actions, and pricing as well as location. And within each of those contexts, there's the idea or the concept of the journey the user takes. Within the booking context, we need to know where the user is picked up. We need to know along the line if there are any stops. We need to know the end destination. Within the pricing context, it's also the journey, but the information we need is the total distance traveled, because we do need that to estimate the price or of the ride alongside every other information as well. And for the location live tracking system, we need geolocation of the ride in real time. Within each of these contexts, we explain the same concept: journey, the route, the path the user takes within a ride, but with different languages in those contexts that explains. Each of these contexts might use the same language, journey, route, but what does it mean within the context? Because we have isolated these units, we're able to proliferate, propagate this same language, but within each of those contexts, they have various meanings that are actually very useful to the team working or people involved within those contexts. Because when you say journey to someone working on live tracking, they do understand it is a business language. They do understand that this is about geo information. When you talk about journey with someone working on pricing rules, how to estimate price, they understand that journey is talking about the distance traveled, and that's an advantage you gain from being able to isolate context, isolate subdomains, have boundaries within those subdomains, have general business language that proliferates across domains without corrupting said domains. Yeah. So basically, all of those were me talking about these benefits you gain from being able to reason about designing software within this bounds and context. And like I said earlier, businesses don't work in isolation. Business units don't work in isolation. They work together to perform a certain process. The whole process of having a customer request a ride, assigning the ride to someone, having someone accept the ride, billing the customer, paying the rider, tracking the progress of the ride. These are all different units within the business, but they work together to perform a certain business function, a certain business purpose. But they do have to communicate with each other. And how do they communicate? Another age-old concept, reactivity, and that's with events. Um, Systems don't notify the world of change by interaction with each other. They don't tell specific, say, subscribers or consumers or units that there has been change within the system. They publish basically, or they announce that something has changed within the system. A ride has been booked, a ride has been paid for, a ride has been rejected, a ride has been cancelled. Um, that's the concept of events within the system, domain event. Within a business unit, notify every other person in the world, every other person in the world. The business remains agnostic, remains non-informed about any other unit in the world, or any other unit within the business, but they all still work together. They all still communicate with each other, and they do that by events. They announce to every other component within the system that something has changed, something has been done within the system, and if you do require knowledge, or you have a function to um, attend to because of this change, then you listen for that change, and whenever that change happens, you react to it. And that's reactivity within our application, being able to think about reactivity there. And again, this is removing coupling or dependency within these systems. There's less direct communication within these systems. Systems don't have to talk to each other. They don't have to know about the internal workings of other systems to be able to process their function. All they have to know is within their context, what has happened, tell what has happened, and if something does change within another world and they are interested in that change, they listen to that change. And why we talk about domain events, this is just like a little boilerplate for being able, for showing events, how this decouples systems. So this is the idea of a ride context, basically a ride concept, a ride object within the domain or within the business. Let's find the outside world that a ride has been requested, and any other person within the system that is interested or is able to react to this information is able to react to it as at any point, because without having to depend directly on the ride, it does not need to know the internal workings of the ride. The ride does not need to know the internal workings of any other system that depends on it. And how do we transport it? Doesn't matter. The whole point of this is agnostic within the domain, agnostic within the business. The business does not care about mode of transport, does not care about the process or the system it's working on. It does not care about if this is working on various computers, various systems. It doesn't care about where this is being sent to or how this is being sent. And all it does is within a certain context, within a certain unit of change, within a certain unit of like modification, it announces to the world or publishes to the world changes that have been made. And obviously this looks all nice and dandy, and a couple of people might notice or might say this definitely is not so great a thing to do for uh, business function. I'll tell you exactly why this is not great. So we all use EF core, and you know how the unit of work for EF core work or the save changes when you so with most it does track data that you get from any data store. So this is just like explaining the concept of publishing within a system. So within a business model, you acquire an object or a business object to perform an action, perform a change. And after performing the change, you want to persist that change to a data source. You are able to persist that change and then also publish that change. Because of the technologies we have, if you're not talking about using Postgres to publish those events, um, if you do try to save those changes, you could save those changes and try to publish that event and have a broken system or a broken state in the system, because those changes could get saved and the system could fail while trying to publish this event. and every other person that's listening to this event does not know this has happened. These messages get lost in the process. A couple of ways you could go about this. They're like change data capture tools, CDC, and they're like transactional messaging patterns like the outbox, and also you could use event sourcing where you actually don't even need, or rather, you don't have um, models that contain states, but basically you models are representation of events that happen in the first place. Again, process of persistence, how you persist, how you send, or how you transport these messages. It doesn't matter. What the business cares about is I've done a business process and I've announced to the world that it happens, and there are ways to make sure make it work.
Funnily enough, that is exactly the reason why the Postgres pub subsystem was developed in the first place.
To ensure transaction within a unit.
Yeah. The idea was that when a record was saved, you could attach a trigger to it,
And
and
then
the trigger
publish
would
it
send pub sub. The developer wouldn't care
about it.
about it. It would just be sent, and whatever was listening in the background would then know that that record had been saved.
So it existed.
That was the whole idea behind it when it was first developed.
So anti-corruption layer. We've spoken about transporting information to other systems, to other contexts, other domains. And we also, in the process of doing that, expose certain information leak, certain domain leak, context leak within other systems. So I'll give an example. This is a notification subdomain, business process that's responsible for notifying users, riders, accounts information, accountants of any of changes within the system. And this is an event that happens within the system, that happens within a domain, within the right domain. A ride has been requested. We send that out to the world. We tell them something has changed. Someone has requested a new ride. And then we push that to everyone, and everyone listening says, oh, yeah, ride requested. And then notification has to go, oh, within ride, we do have to record the journey. There's a concept of journey, there's a concept of requested time. These are information that, or rather, these are information within the system that the notification domain has no reason being aware of. It should not be aware of this information, being having to handle filtering or data, basically knowledge of those domains outside the system. That becomes a problem, because then we go back to where we are coming from, having each of those systems talk to, know about each other, be aware of each other, having the system that sends out the information be aware of the type of information it has to send out, because its consumers expect this certain type of information in this format, or needs this sort of words, or having the consumers be responsible for mapping from the language of another domain into their own language. And toolkits that could help with that, anti-corruption layers are basically just abstractions or in front of systems that reads data, transforms it into how I expect it to be, and the only thing my domain, my system knows or gets in is what it should know in the language it should receive it in, and that's the only thing it resolves. That's more moving parts in the system, more expensive, but again, toolkit in your tool set, use it when it solves a problem for you. Technical patterns. All dandy nice with the strategic patterns, how it works, but how do we design that in software? How do we make it work in software? And with domain-driven design, there are three major concepts when it comes to reasoning about designing and modeling object components, business components. And those are the value object entities. And we'll ignore the aggregates for now. We'll go back to the aggregates in a bit. And basically, objects in systems in general, or rather the entire idea of object-oriented programming, is behavior. What behavior does this object perform? What behavior do we expect this object to perform, rather than its um, properties, rather than it's not a record, it's not a data store. It's basically something that does something. And to model systems, or to model business components, we try to identify how business sees, how business components exist, or rather how business components basically function. What are business components? What are the types of components that exist within a business? And try to identify two types of those components: components that have a life cycle, that have an identity, that exist through a life cycle. I'll give an example. I am a component. I have like a life cycle from when I was born to whenever I'm no more. And within that process, I'm able to do a couple of stuff. The government knows when I was born. The government is able to track me or know who I am by a particular identifier at this point in time, possibly my name, or the information on my visa. So at each point in time, or from the concept of that object, of that process within the business needs to identify this particular component. It needs to know when it was created within it. It needs to know, be able to track each action it performs within the system. We need to know when a ride was created. We need to be able to identify the ride, have it perform actions and functions throughout its life cycle till a certain point. But we at every point need to know that the ride we are performing an action against is this ride. The user we are billing is this user. We're not just billing all users, or we're not just billing a user, but we are billing this user. And that's what an entity is a component, an object that you design in a way that you're able to track by a unique identifier, you're able to maintain, manage life cycle. And a second type of object, value objects. Why are they important? They perform action as well. They're not just records, but their existence, their action, their function is actually as a result of their properties. Perfect example is money. Um, you could add money, you could apply discounts to money, you could do a lot of stuff to money, but £5 would, this £5 is that £5. Uh, a bank sees £5 different because they do identify them by unique IDs, but to businesses, to my ride hailing app, I don't really need to know which £5 was sent to me. I just need to know I did receive £5. I need to receive the information about the currency and the quantity, and those are the only information the money tells me. It is an object within my system that performs an action, but I do not need to know its identity. I do not need to track its life cycle. I maintain that object. I perform actions via on that object, and those are value objects. I've shown a little code snippets on example of both of those and applications. Perfect example, money. Immutable. That's something very important. These objects are um, designed to be immutable. So when you apply changes on them, you're basically just creating a new object, but it doesn't matter, you're creating the same object. What you're creating is a new state. So basically what you're passing around is the information, the state. You're applying behavior. It's not acting as a record. It's an object that has states, but basically has behavior, but the state is ephemeral, the identity is ephemeral. What you need is the information and the current state at every point in time. Currencies. Yeah. Yeah, just a few more. Yeah. So I'll be leaving soon. So, anyways, next one is the entities. I've just shown a little bit more example for that as well. Basically, tracking an entity through a unique ID, through its life cycle, being able to perform actions on that entity from beginning to end, even after its use is still alive within the system because it did exist at some point within the system. We do need to know information about it from when it entered the system till whenever, depending on yeah, auditing needs, whatever needs you need to perform the action against. But you always have information with be able to build basic a encapsulation boundary of that object within its entire life cycle. And repositories, yeah, pain points. EF Core worked beautifully. Lot of other ORMs work beautifully as well. But again, the entire idea of domain-driven design is abstracting technical implementation from or technical details from the domain. The domain should not or does not need to know about model of persistence. It does need to know that there is persistence. It does need to know that these objects do not live forever within this context. We are ephemeral. We retrieve this object, we perform action on it, and then we persist it to another state. But do we need to know how we persist it? Do we need to know which product or which tool we're using persisting it? The business does not need to know. That's an example, just like a contract for a repository. I was going to show earlier a little demo of why this repository works, even though again, entity framework does solve a lot of problems of having to have repositories because it does again, it's a very it's a good piece of tool. Um, Building UI for the application with rich subdomains, rich business context. I would go straight to here. Image one looks a whole lot like where we came from. Having our context within the UI, different parts of the system, working concurrently or collectively to build up an output or collect information from a user. So when we take information from a user, we have to mandate every part or different contexts to work together to perform that process because we've all bundled them together. The whole entire idea of abstraction or separating the business, it becomes, we take a step back because we go back to where we started from, where we have interaction within different domains or trying to perform actions, make business rules within a certain command or a certain information. And in order to mitigate that, we slap basically what's called an application counter and application UI. And what it does is basically orchestration within between different contexts, between different external services, all to contract, no implementations, all to contract. So basically, orchestrate a business use case, orchestrate a business process, define contracts of business processes that could be or can be resolved, and orchestrate through a certain or a single product, a single system, a single unit. And beautiful thing you could do with it, um, slap a pipeline in front of it if there are common processes, say authentication, validation, exception handling. Um, Stop having loads and loads of individual exceptions within processes, trying to figure out what breaks and where what doesn't break, because again, everything happens within a layer of abstraction, a contract. Challenges with domain reporting. So we've spoken about our business trying to organize our business process into different subdomains. The beautiful ways of thinking about system like the value objects, the entities, and this works for individual units of actions. It works for building a ride, requesting a ride, billing a customer. You aggregate um, components, value object entities within a single customer command, a single customer request, and you perform actions against that. But what about reporting information to users? Software products both take action from users and report information to users when they ask for them. And within those different contexts or different subdomains, information you report to users could come from a lot of places. It doesn't have to. Most of the time, information wouldn't come from a single context. And how do we avoid modeling our carefully designed and so beautifully designed business application? Little tool or design tool called CQRS. Again, another keyword, another buzzword, but it does work when it's needed, and this is one of those times. Reporting consents are not often the same as transactional consents. This has long been in databases. This has been done in databases for a long time. When designing databases, you think about designing when you're designing transactions for you're designing data applications for transactions. So that's the difference between OLTP and OLAP, and transactions for analysis. The needs for both information are totally different. The shape both informations must take are also totally different. So that's basically CQRS for you, is thinking about segregating your application, your toolkit, into making actions and reporting information to users. When reporting, aggressively optimize in any way that makes it possible to get all the information you need as fast as possible. And when performing a business function, a business rule, you need the carefulness of composing, aggregating, ensuring invariance, ensuring those rules occur before any mutation, any change in state within the system occurs. Yeah.
Basically, media.
Yes. And those are examples of being able to separate concerns between two different contexts, making mutation within the system and asking information from the system. The infrastructure, very short, very glance through. It doesn't really matter what tools we use. The tools do matter, obviously, when it comes to how well the software does what it does. But to the business function, to the business process, the tools do not matter, and that's why we carefully try to design to contract, so that we're able to decide the tool that works best for us. Start with whatever tool works best for you, is suitable cost wise to the team at that point in time. And most often than not, teams don't change tools that they use. It's always idealistic that tools will change sometime in the future. It doesn't change a lot of times, because most tools do what they do well when you do start to use them. But the point of having being able to separate your application from the implementation details is so that you're able to have clarity, you're able to focus on what the business does rather than how it does it or what tool does it. And then presentation is basically IO, is user IO. Get information from user, take it through your system, do whatever you need to do to your system. When users need response, collect the response that they need back from them and send it back to them. And yeah, so I'm not going to go through the pros and cons of this, but basically, I hope I have been able to, within the talk, sneak in pros and cons of having to think about domain-driven design. Do I have any other thing I want to show? No. So if you do want to contact me, please do reach out via email. I should have put my LinkedIn on this. I would be sending it over to Kasim. And also check out this lib. So I'm currently writing a class library for distributed applications in .NET. It's not commercial. Basically, these are just patterns and implementations using different tools as well and abstraction. So you're able to get started with distributed systems real quick in .NET. Awesome. Thank you very much.